Here in this video, we're going to look at graphing exponential functions. And the exponential functions we're going to be working on graphing are all going to be in the form of y equals a times b to the x power. And we'll get to this a little bit later, but a, the number that's in front of the term that has the exponent of x, is the initial value as long as I don't do some kind of translation in the exponents. And b, which is called the growth or decay factor, and it helps us identify if we're growing exponentially or we're decaying exponentially, and we can also use that number to find our rate. Now, we're not doing all that in this video, but we will be doing that down the road. So this table is something that we're going to refer back to a little bit later. But what we want to do is we want to graph these two functions, and then we're looking at the graph, can we make a prediction as if this is growing or decaying? Well, to make our graph, we're going to create a table of values. And I already pre-selected some values here for us to use. We're going to go from -3 to +3 for both of our problems. And so I just need to get the y numbers that go with it. So if x is -3, I need to get the y. I'm going to put the -3 into my problem, which is right up here, where the x is. So I'd have 3 times 2 to the -3rd power. And then we'd have to try to evaluate from there. So, well, we have to use properties of exponent. So 2 to the -3rd power, I can make it positive if I move it to the denominator. So it'd be 3 over 2 to the 3rd. And then remember, 2 to the 3rd power is really 8. So I have -3, 3/8. So I'm going to go put that on my graph. So -3, and then 3/8. Well, 3/8 is almost a half, but it's not quite there. So I'm going to go like right about in here. Now we'll go to the next one. All right, so -2 goes in now. So I have 3 times 2 to the -2nd power. So that makes 3 over 2 to the 2nd power, which is 3/4. All right, so -2, we get a dot at 3/4. So -2, you get a dot at 3/4, so something about right there. Now we put in -1, so 3 times 2 to the -1 power, which is going to be 3 over 2 to the 1. So -1, we go to 3/2, so that's really 1.5. So -1, we go to about 1.5. Now we put in 0 where the x is. So that'd be 3 times 2 to the 0 power, which is the same thing as 3 times 1, which makes 3. So when x is 0, y is 3. Okay, so 0, 3. And then we keep going to get more numbers. So we put in a 1 for the x, so 3 times 2 to the 1 power, which makes 6. So we go to 1 on the x and go 6 on the y, and that gives us a dot right here. And now we keep going. We get 2 more numbers. So we put in a 2 for the x. So we have 3 times 2 to the 2nd power, which makes 3 times 4, which gives me 12. So I go to 2 by 12. So 2 on the x, 12 on the y. I get a dot right there. And then the last one was the 3 to go in for the x. So we'd have 3 times 2 to the 3rd power, which is the same thing as 3 times 8, which gives me 24. So I'd go look at my graph, and I don't have room to go put that because 24 would be like somewhere up in here, and I don't have a number for it, so I don't have a point to place. So what we're going to do is we're going to try to connect those dots the best we can with a curve. And so we're looking at what's going on. It's not really a straight line. This graph is curving, and it's getting a lot steeper as we work our way to the right. Now, the question is, what is happening as we go this way? Now, exponential functions, what they do is they get very, very flat. As you go to the right, what is happening is this graph is going to get closer and closer to the x-axis, but it's never going to actually get there. It's actually called a horizontal asymptote, which you learn later, but this graph approaches the x-axis and it gets real flat right there. And so this is the way our graph looks, and we'll put arrows on the end because it's going to continue on forever in both directions. Now, to answer the question, is this growth or decay? Well, it's the same way we determine this based on if we are reading our graph for increasing and decreasing in a sense. All right, so we don't have anything crazy going on. We haven't flipped the graph, or there's no negative signs out front. Just for your standard y equals a times b to the x problem, if as you go to the right, the graph goes up, it's going to be considered exponential growth. So this is an example of a growth problem. All right, let's do the same thing again. So here in this next one, I want to get some points to fill in a table for y equals 2 times 1/2 to the x power. We're doing the same coordinates that we have. So we'll start with -3. So I got 2 times 1/2 to the -3rd power. All right, well, 1/2 to the -3rd power is the same thing. You flip that 1/2 when it has a negative exponent, and so that makes 2 to the 3rd. So 1/2 to the -3rd power, same thing as 2 to the 3rd power, which gives me 2 times 2 to the 3rd, which is 8, which is 16. So I have -3 comma 16. So -3 comma 16. And I get a point. Then we go to our next number. All right, and so we do the same thing again. So we get 2 times 1/2 to the -2nd power. Now, if you don't understand how the 1/2 to the -3rd became 2 to the 3rd, I'll do this one up over here to the side. So remember our properties of exponents. If I have 1/2 raised to the -2nd power, I could apply that exponent to the numerator and the denominator separately. And then to make our exponents positive, I would move things to the other side of the fractions. And 1 squared is itself, so I end up with just 2 squared. So 1/2 to the -2nd power, same thing as 2 squared. That's what I'm doing here. And we did that in class. So we have 2, we're going to rewrite this as 2 times 2 to the 2nd, which makes 2 times 4, which gives me 8. So I'm going to go plot the point at -2, +8, and then we'll come back and do another one. So at -2, +8, I get a coordinate, and then we keep going. So now we do the same thing with -1. So 2 times 1/2 to the -1 power. That's the same thing as 2 times 2 to the 1 power, which gives me 4. So I'm plotting a point at -1, 4. All right, now we put in 0 for the x. So 2 times 1/2 to the 0 power. Well, 1/2 to the 0 power is just 1. So I get 2. So I have a point at 0, 2. So I go to 2 on my y-axis and put a dot. We continue on here. Now we're putting in a 1. So 2 times 1/2 to the 1 power is 2 times 1/2. Well, 2 times 1/2 is 1. So we got a coordinate at 1, 1. And so I'm putting a dot here. So we're starting to make that turn, and we're starting to get a little flat now. Now we're putting in 2 for the x in the exponent. So 2 times 1/2 to the 2nd power. 1/2 squared makes 1/4. 2 times 1/4 makes 1/2. So at 2, I put a dot at about where 1/2 is. I'll zoom in here, dot about halfway there between 2 and 1. I got one more point. So we'd have 2 times 1/2 to the 3rd power. 1/2 times itself 3 times makes 1/8. 2 times 1/8 makes 1/4. So at 3, I put a dot at about where 1/4 would be. All right, so we got all these dots here. Now let's connect our dots and try to make a sketch of what this graph would look like. So it's got to make that turn, and it starts getting real steep. It's going to continue going on to the left that way forever. As it goes to the right, it's not going to cross that x-axis. It's going to get very close to it, and it flattens out. So we have our graph. We figure out, is this growth or decay? Well, as we go to the right, we're going down here. This is going to be exponential decay. Now we can also tell this. Notice the difference in the two equations. When we were growth on the left, the number that had the exponent was bigger than 1. And when we were decay on the right, the number that had the exponent is smaller than 1. So that's how we would tell this, just by looking at the equation.